Hello, welcome to another problem session. So this is a very common contest problem as well as kind of trick problem in tests. So we have a cork which is kind of floating. Some part of this cork is floating up and some is under water. And this is a situation when acceleration is zero. So this is a situation when acceleration is zero. The whole thing is in this water and this is elevator. So when the whole thing is accelerating, will this thing pop up or it will sink further? That's the question, And I might ask how much if it sinks. The question is accelerate, sink more or sink less, or nothing happens, nothing. It's like it remains the same. So there's three possibilities. Okay, and if it sinks more, then you should tell me how much more it sinks. If it sinks less, then you could tell me how much less it sinks. Sometimes this problem can be given in a nice situation that this area is A and this height is H, and initially maybe underneath was zero initially when acceleration is zero, and then you can give me in terms of H0, okay, whether H0 is going to be high or less. All right. How would we do this problem? We can do it a couple of different ways. We can say this is the y-axis, and so on the cork you can say Fy equals to mass Ay, and this Fy will be forces on the cork, and MAY will the mass of the cork. And so this is done in an inertial frame. So this is something that's fixed. So this is the inertial frame. So that's one way to do it. Another way to do it is attach a frame to the elevator, okay, and so the frame has acceleration A with respect to this. So this is accelerating frame. So when you do in the accelerating frame, you have a fictitious force, you probably know. So now when I'm here, the cork is not accelerating anymore. So now acceleration of cork is zero. So this law changes. So you have original force, and then you have additional force, which is mass times Ay. This is from the frame, and these are the same forces. This is equal to zero. It kind of comes out like this. Okay, so what are the original forces? Well, the forces are going to be, if you look at it, you have a weight of this, so mass times G, less cork has mass M, and then you have a buoyancy force. Buoyancy force is going to be now, if you remember, it's going to be mass displaced fluids, mass of the displaced fluid, time used to be G, right? So Okay, so when it's not accelerating is G, and that comes from the pressure formula. But the pressure formula now would be G plus AY, because if you look at why would be this buoyancy force, so it's let's look at a little example here. It comes from buoyancy force comes from pressure different from at different levels. So say I want to know pressure here versus pressure here, and so this is some part of a fluid, and let's say this height be h, and we write equation motion for this as in some acceleration ay going up like that. So you have a p0, this p is p plus p0. So I want to know what this p formula for this p will be if the height is h. So how much, so this is like a mass of this, let's call it big M here, mass of this, its weight is going to be mass times G, and so upward pressure will be this times this area, so P times area, and P0 times area, this will cancel out. So as a result, this guy has an acceleration AY. So if I write this like this, P times area minus mg equals to m times AY. And so the pressure is m AY plus G over A. And this m is density of the fluid is rho 0. This area is A, this height is h. So rho 0 h G plus AY. So the pressure formula when it's accelerating in that direction, the pressure formula is this, not rho GH. So the buoyancy will come out, because it comes from the pressure formula, will come out like that. So we are going to get, let's write down, so this is volume of the displaced fluid. So let's call it volume of the displaced fluid for times the rho 0. So that's the mass of displaced fluid times G plus AY. So this is come from the buoyancy upward minus the mass of the cork times G, the weight of the cork. So this is the buoyancy, and this is the weight of the cork minus my equal to 0. So if I look at it, when the acceleration is going on, we again get BD amount displaced. This is the volume that's displaced. That's the volume down here. So volume displaced is equal to m, and G plus AY got cancel out over rho 0. G plus AY in the numerator, G plus AY in the denominator, they cancel out. So actually this is a displaced fluid is independent of AY, which means it's neither going to sink nor going to float. So the critical part is the buoyancy. Buoyancy comes from pressure, and pressure in the accelerating fluid is actually not rho GH, but rho GH plus A sub Y. So if it's going down, A sub Y will be negative. If it's going up, it will be positive. So if I ask the question, a different question, like if I ask, I have a fluid, and so what's the pressure here if I accelerate the fluid with AY, I will use this formula. This will be P will be atmospheric pressure plus rho 0 H G plus AY. So this is a different question, but because buoyancy uses this in its derivation, this G will have to be modified by G plus AY. Okay, so that solves the answer. So answer is actually this part. This is correct answer. Let me pause it and show you something else you can solve. Okay. So there is this problem that comes up very often, and is in my website. Cork is here, and there's a tension in this is string. Tension is T0, and I put this whole thing in an elevator and make it go to acceleration A. Then what's the tension? Again, you can actually just look at this cork, and you can say, well, I got its weight, I got buoyancy, and cork has less density than water, so the tension is down like this, and this whole thing is accelerating upward with an A. And now you know what the force of buoyancy has to be, because the cork is fully submerged. So use the formula for cork buoyancy formula, and then weight of the cork and tension. So you can see the force of buoyancy will be now volume of the cork, whole thing is submerged, times rho 0 times, it's going up, so it's going to be G plus A. So that's the buoyancy force. And then you have a weight of the cork, that's going to be negative, and tension will be negative, and on the other side will be mass times A. So I bring tension on this other side and MA on this side, so this just tension just becomes equals to this FB minus M G plus A. So this is another application of accelerating frame and how the buoyancy changes when frame is accelerating upward or downward. Okay, that will be it. I probably will move on from here. Next we're going to talk about surface tension in the next video. I'll talk to you later. Bye.